Hello, everybody. This section is 5.5, differentiation of logarithmic functions. And it is last section in this chapter. So we're going to see the derivative of natural log of x, which is here rule number 3. The derivative, of course, we're using the absolute value of x, or the argument here to be positive because of natural log does not take negative inputs, of course, and x cannot be 0. For this differentiation to happen, of course, the function has to be there and be continuous. So when you differentiate, it's just going to be 1 over x. So, of course, this is the simple form of it. And let's just show you the other form, which is rule number 4. Now, if you have not x, you have f of x. So you remember when we use a chain rule and in the calculations and all that, when it's not that basic form. So if you don't have x, you have f of x, then you will carry it by doing f prime of x, which is the derivative of the inside divided by f of x, which is the inside function. And f of x need to be that positive, strictly positive function. All right, so let's start with the first example. Of course, now the other way, just if we do this, then we differentiate with respect to x, of course, right? And that derivative is 1 over x. So here, if we have an example, let's just put examples. Let's say example 1, and you have a and b. F of x is x ln x, which is a multiplication, so we use the product rule there. And by using the product rule, we keep x, we differentiate the natural log of x, then add, keep natural log, and differentiate x. So x, the derivative of natural log of x is 1 over x, and the derivative of x with respect to x is just 1. So it's 1 plus ln x, or natural log of x. For the second one, you have natural log of x divided by x, so you're going to use the quotient rule, right? So we do that denominator square, we do the denominator times derivative of numerator minus, and we switch them, and we do it now again the same thing, and now you have 1 minus ln x divided by x squared, just like the other one. So differentiation rules still apply. If you have a product, you use the product rule. You have the quotient, you do quotient rule. Then you move on with each one, what is the derivative of each one, then you simplify. The chain rule and the logarithmic function is the second one here. So the outside function is ln of x, ln, and the inside function is f of x. And if we want to differentiate this with respect to x, then we're going to do that inside function derivative divided by the inside function. All right, so applying that chain rule. Of course, the same restriction here applies of that f of x needs to be strictly positive. So it's simple. Let's say example here, example 2. If we want to differentiate this, then we first need to write it in. We have a natural log of. Let's say you have natural log of a times b. Then you can do a natural log of a plus natural log of b. So you can do that, right? Let's see if we can. You won't erase, but Let's see if we can make it nicer. If not, then we leave it as it is. Okay, so we have this times this, so we can switch it. This is just applying the rules of properties of the logarithmic. So now we have that. Then we can use the other rule of the power rule, ln a power, let's say b, then it becomes b ln of a. All right, so the 6 comes to the front, and now we have, this is the y. So now we can apply the chain rule. So this, for this one, this will be the f of x. So you're going to have f prime of x divided by f of x for the derivative. And if this is g of x, then you're going to have g prime of x over g of x. And of course, the 6 here is a multiple. So that's this step here. So the derivative of x squared plus 1 is 2x. The derivative of x cubed plus 2 is 3x squared plus 0, which is 3x squared times 6, and we get this derivative. So it's just a combination of knowing the logarithmic properties to simplify, then using the next, this chain rule. So logarithmic differentiation is a nice method, and let's talk about it here and kind of explain it. So let's say to differentiate y equal x times x plus 1, x squared plus 1, using logarithmic differentiation. First, we take the natural log on both sides. So, and I'll explain what's going on. So, if you see this here, you have y equal x times x plus 1 times x squared plus 1. So, this is logarithmic differentiation, this method. If you take a natural log to both sides, what's going to happen just like the previous example. You're going to change this product into a sum. So it's going to be what you see here. When you do take a natural log to both sides, you're going to have the ln x plus 1, ln x squared plus 1, just like the previous example. Then if we differentiate both sides with respect to x, what's going to happen? You're going to have, of course, this derivative of y prime, and these are going to become easier because, as you see, like this one is rule number 3, this one is going to be rule number 4 or rule number 4, right? So 1 over x, the derivative of x plus 1 is 1, the derivative of x squared plus 1 is 2x. Then you get that derivative here, y prime. So to evaluate this left hand side, note that y is a function of x, right? So we can write y f of x to remind us of this fact here. So this derivative is same as this ln of f of x, right? So you can see that in this form, this logarithmic differentiation makes it easier to do, because as you see in this example, you have the x times x plus 1 and x squared plus 1. And by taking the natural log to both sides, it became instead of multiplying and folding and all that, it just became a sum that you can do each one by itself. And once you have each one by itself, then as you see here, the derivative of ln y So what is, of course, y is f of x, right? So because y is f of x, as stated here. And because of that, what is the derivative, of y based on rule number 4 is f prime of x over f of x. So we can change that to y prime over y. So this left side, it becomes y prime over y, which is this. So now to find y prime, you're just going to multiply by y both sides. And that's going to give y both sides. When you multiply by y both sides, it's going to cancel from here and it's going to show there. And then, of course, you back substitute. What is the y? It's this. It's the function you started from the beginning. So you see a problem that could be kind of long or difficult. Maybe you have x to the 10th at the beginning. And you're gonna FOIL many times, and that this logarithmic differentiation makes it simple to do. So what are the steps for it? This, to summarize this logarithmic differentiation, is you take the natural log to both sides and use the properties of logarithms to write any complicated expression as a sum. So you may use from the product to a sum. You may use the power rule to bring the numbers to the front, stuff like that. Differentiate both sides with respect to x, solve for dy dx. Let's look at two examples from the activity, and let's see, do we have them here? I think I'm going to post them and we can work on these. So and this is number 1. So find the derivative. Looks like this is row number 4. So you will need to do g prime of x is going to be the 4x plus 3 prime over 4x plus 3. So it's going to be 4 over 4x plus 3. And same for this number 2. We have a multiple. So h prime of t, it's going to be this multiple here, and we're going to do the derivative of this inside over itself. So it's going to be a 24 by 6 times 4, and t3 will cancel with t3 from here, and you'll have 1t left. All right, I think that's all for this one. Thank you.